Welcome back. In the last video, Unit 7.1, we talked about SAS as short-term memory. In this video, Unit 7.2, we'll talk about SAS as working memory. Keep in mind, short-term memory and working memory are the same thing, SAS. It's a different way of looking at it. Initially, researchers had a very simple conception of SAS as a short-term memory. Later on, they developed a new, better, and a complex version of it called working memory. We'll talk about SAS as working memory in this video. What is the difference between this and working memory? It is a way to explain different phenomena, right, that result in conceptualizing SAS as short-term memory. The simple conception of short-term memory as a single store that holds limited amount of information for limited amount of time is sufficient to explain simpler tasks like reading a list of words, but it becomes difficult to explain more complex tasks. For that reason, Badley and Hitch developed a multi-component system as opposed to a single box. It's a multi-component system with each component having its own limited capacity. This way of conceptualizing SAS as a working memory, it's effective in explaining simple tasks and complex tasks. Before we talk about this model, I just wanted to try and answer this question. Try not to use pen or pencil, try to do it in your mind. What is the answer for this? I'm pretty sure you came up with the right answer. Here is the question. How did you solve this problem mentally? Well, usually people say that I added these two and multiplied this with this and held that number here and then took these two and added this two and had this number, then used this particular marker to divide this by this. Held information, did multiple things. This is hard to explain using a simple conception of short-term memory. Another example would be imagine you are working at drive-through place, and what do you do there? You take order from one customer and you talk to other customer. You swipe the card of the second customer while you're taking order from the second customer. So there are multiple things that your mind does for a given task. To explain it, Baddeley and Hitch proposed the first model of working memory. There were several other models presented at that time, but the most popular one was Baddeley and Hitch's model, which of working memory, 1974, and that's what we'll talk about. When they initially proposed the model, it had only three components: the central executive, phonological loop, and visual spatial sketchpad. Later on in 2000, they added the fourth component, episodic buffer. We'll talk about each of these components in this particular video. Badley and Hitch's a working memory model. It's a multi-component system. It has one main component called central executive, subcomponents: phonological loop, visual-spatial sketchpad, and episodic buffer. These components are interconnected and specialized in processing specific kind of information according to this model. For instance, phonological loop is for processing auditory and verbal information. Visual Spatial Sketchpad, or VSSP, is for processing visual and spatial information. Episodic buffer is for integrating different kinds of information, so there is a sync between visual and auditory and other sense information, so you get a complete experience. Before we talk about the individual components, there was neurological evidence supporting a multi-component model. One evidence came from this particular patient who had short-term memory span of 2. In other words, he can only hold two items, yet the individual had normal cognitive ability to learn, memorize, and comprehend information. It's hard to explain with simple conception of short-term memory, which can only hold two items, explain how this individual can normally perform cognitive abilities. A better way to explain would be to have a multi-component system. Short-term memory is only one aspect of one of the components to hold some information. In other words, short-term memory is only one aspect of a bigger, complex multi-component system. In the next slides, we'll talk about each of these components in detail. The main component is the central executive, CE. The other components are phonological loop, VSSP, and episodic buffer. First, we'll talk about central executive. Central executive is the main system. Remember, we said this is the seat of consciousness. Well, according to working memory model, the main component of SAS that makes you aware of things is the central executive. It makes plans for future actions. He makes decisions, takes moment to moment decisions. If you decided to pay attention to what I'm saying or decided to get distracted, whoever is making the decision of what to do at any given point of time is the central executive. Remember, it's all about attentional resources because SAS is attentional resource as well. Central executive assesses attentional needs depending on what you're doing. It assesses attentional needs of individual components and allocates required attentional resources. It keeps track of attentional needs of individual components and keep allocating and reallocating. But keep in mind, even the boss can run out of fuel because attention in general is limited. Another way to think about central executive is to think about it as CEO of a large company. Now, CEO doesn't work. He makes important decisions and delegates work to the managers or the employees. He doesn't even look at the work of individual employees, but allocates or delegates work to the managers who in turn will take care of the work. So also this person makes moment-to-moment decisions, important for central higher cognitive functions. And it integrates information taken from multiple components to make bigger decisions. So the central executive is the important part. That's why this is the main system and these are called subsystems or auxiliary systems. Let's talk about the first subcomponent or second component of the working memory. It's the phonological loop. As the name suggests, it is for auditory and verbal information. When we say auditory, it is the information that you receive. You're hearing my voice right now. You're processing auditory information. When you speak, you also produce sound. Your mind also processes what you produce. That would be verbal information. Phonological loop processes both auditory and verbal information. Phonological loop is further divided into two subcomponents. One is phonological store. The other one is the articulatory process. Now keep in mind, the name itself gives you enough information. One is more like a store, a system to store, hold information. The other one is more like a process to control the information held in your phonological store. That's exactly what it is. Phonological store is like your inner ear. Try to say something in your head. Say tree, for instance. Now, when you said tree in your head, that sound is held somewhere, as if there's an inner ear. Imaginary analogy. That is phonological store. It's your inner ear. It passively stores the sound. When you created that sound in your head, like Shri, not out loud, but in your head, that is the articulatory process. Articulatory process is active process of holding information in the phonological store. It's like your inner voice. If you remember from the last video where we talked about how can we hold information for longer than its duration, then one thing we said was that you can do maintenance rehearsal. Maintenance rehearsal is repeating the word in your head over and over again. That repetition is because of articulatory control process. The phonological loop has two structures: phonological store, which passively stores information, auditory or verbal, an articulatory control process which maintains actively the stored information. Okay, we'll talk about phonological loop related phenomenon related to phonological store and articulatory process. The first phenomenon is related to phonological store and the next two phenomena are related to the articulatory process. The word length effect is the finding that it's harder to remember longer words than shorter words. Participants are presented with a list of shorter and longer words. Their accuracy is higher with the shorter words when compared to longer words. This is because of phonological store. It makes sense because of the limited capacity of the phonological store. If the words are longer, they occupy more space. The next phenomenon is the phonological similarity effect. It is a finding that it's harder to remember a list of similar sounding words when compared to dissimilar sounding words. Researchers found that it's easier to remember dissimilar sounding words than similar sounding words. This phenomenon is called the phonological similarity effect. Well, what could be the reason here? Well, one reason could be that if both the list of items have same number of syllables, in the phonological store, is same. What is different is how you are retrieving the stored information, and there could be confusion in terms of repeating or retrieving similar sounding words as when compared to the dissimilar sounding words. So it will be harder for the system to retrieve similar sounding words. So that's why the memory accuracy suffers. So, well, the reason is due to articulatory process. The last phonological loop related phenomenon is the articulatory suppression. Articulatory suppression is when you suppress or prevent rehearsal of words. Let's do this. Do this with me. I want you to tap your finger on a table, laptop, or your computer with me. Here we go. Do you hear the sound? While you're doing this, I'm going to give you a list of words. You're going to listen to this list of words and try to remember. Okay? Let's do this. Pen, book, chocolate, flower, pouch. Now, can you recall what are those words? It was easier, right? I'm pretty sure it's easier. Now let's try to do this one, okay? But I want you to repeat this sound. I want you to tap, okay? Now do this. Say with me the the. Keep repeating. Don't stop. Come on, keep saying. I can't say now. You have to say it. The louder. Okay, now I'm gonna give you sounds. Keep saying. Now I want you to remember these sounds. Keep saying. I can't hear you. The yes. Keep saying. Bicycle, mat, phone, chocolate. Okay, so can you recall now? It's a bit harder, right? The reason is because you were saying the. It prevented you from rehearsing the list of words I gave you. This process is called articulatory suppression, which is preventing rehearsal of words or sounds is articulatory process suppression. So articulatory suppression is related to, well, it's articulatory process. Now let's talk about the third component, Visual Spatial Sketchpad. It's also called VSSP, Visual Spatial Sketchpad. This subsystem is specific to processing both visual and spatial information. That's why it's called Visual Spatial Sketchpad. Visual is a two-dimensional picture or image processing. Spatial is three-dimensional, where you're also taking into account the spatial aspects of the information. One interesting thing about the Visual Spatial Sketchpad is the processing is not static. The processing in Visual Spatial Sketchpad is in real time. In other words, you would process information in this VSSP as if you're processing in real time in the real world. Okay, and we'll talk more about this when we talk about the different VSSP related phenomena. Real time is you process visual and spatial information with an intention to interact and react with the objects that you're watching. What does it mean? Well, it is related to embodied cognition. Remember, we talked about theories of text comprehension or comprehension in general, and we talked about embodied cognition, and we said comprehension is not merely extracting propositions, but also simulating what you read, so you create this story in your head. Well, it's more than that. Have you seen horror movies? Well, I don't, but my wife likes horror movies. What happens when you watch horror movies? Well, you startle, right? You respond as if you're a part of that particular movie. There's no need for you to startle because you are not in that situation where the story is unfolded. You're outside the TV, you're in your bedroom, you're watching the movie. There's no way for you to feel scared. Yet we do. The reason is when you watch a video, you become a part of it. Your visual system, especially VSSP, process visual information with an intention so you can react and interact. So this is embodied cognition, and there are three phenomena related to VSSP and that we'll talk about now. One is mental rotation, the other one is boundary effect, and the third one is representational momentum. Mental rotation is related to angle of rotation. Shepard and Metzler presented participants with pairs of objects like these, where the second object is either a match of the first object or a different object. The participants have to say if it's the same object. For the pairs of objects that were same, the second object, the researchers manipulated the angle of rotation. So the second object is either rotated to a smaller or a longer degree of angle. So the IV was the degree of rotation of the second item. And they measured how long participants took to respond to these items. And what they found was a direct relationship between angle of rotation and the time taken to respond. There was a linear relationship. With the increase in angle of rotation between the first and the second object, the response time increased, as if you're manually rotating the object in your head till you get to the second object's image. This suggests that VSSP processing both visual and spatial information in real time, as if you're processing it manually. The next phenomenon that's specific to VSSP is the boundary effect. Boundary effect is remembering more of visual scene than what is given to you. Typically, when participants are presented with pictures like these, later when they're asked to identify, they would always select an image that has more information than the information that was originally presented. So the idea here is that when you are processing an image like this, right? This is the actual image. What VSSP does is it stores this actual image, but it also adds additional information related to these images by bringing it in from long-term memory and storing both the actual image and the additional information that you added in your long-term memory. When asked which image did you see, you select the ones that has more information because your long-term memory stored not only the actual image but also the additional information that your VSSP has added to it by pulling it from the long-term memory. And this is called boundary effect. Representational momentum is misremembering the position of an object farther along its path. Now imagine I throw a ball at you, and let's say you're here and I throw a ball here from here. Now you need to be able to predict the path of this ball for you to locate where it's going to fall so you can go there and catch the ball. But you don't need to do that when you're watching a video of somebody throwing ball. Visual Spatial Sketchpad actually does that. It imagines that you are in the scene that is depicted in the video and prepares you to react and interact with the objects so that you keep track of the object although you're not required to. In experiments of this sort, what typically happens is participants see a moving object and the object disappears at a particular point. Participants would be asked where the object disappeared. They have to identify the point where the object disappeared. Usually, participants would report the object disappeared further along than the actual position where the object disappeared. In fact, not only further along, but along the path of the object. In other words, they predicted the path of the object. That's why they did it. So this misremembered the position of the object further along its path. That only happens when your system is processing as if you are a part of the system. So what VSSP does is it stores the observed path, then it adds the predicted path, assuming that you're gonna interact with it, and stores both. That's why people misremember the position of it further along, and not just further along, but further along the path of the object. This is called representational momentum. This is one reason why VSSP is embodied. It processes information in real time. The episodic buffer is the last subcomponent. It is the one that was added in 2000. It integrates information from other components of working memory, like VSSP, the phonological loop, from other senses, and also from long-term memory. It gives you complete experience. Imagine watching a video with no sync between audio and video. You'll see the lip movements first, then you hear the sound. It doesn't make sense. I'm just using two modalities here, but think of all possible modalities. There should be a system to sync these things so that you'll get a complete experience. That's what episodic buffer does. It's connected to, if you remember from the bigger picture video, your long-term episodic memory, which stores your personal experiences. There is one particular phenomenon related to episodic buffer. It's called reverse phonological similarity effect. Remember, reverse phonological similarity effect is because of the episodic buffer. In experiments specific to episodic buffers, reverse phonological similarity effect, participants typically go through working memory span test. Participants would listen to or read a series of sentences, and the last word of the sentence is what they are supposed to remember after a series of sentences that they have read. Working memory span would be your recall accuracy. If you remember 7 sentences last words, your working memory span would be 7. What typically researchers do in experiments of this sort is they manipulate the last word. The last words of these sentences are similar or dissimilar. In other words, they either rhyme or don't rhyme. And they measure the number of words remembered. What they found, the similar words are remembered better when compared to dissimilar words. This is reverse phonological similarity effect. One reason why, if you think about it, to give you a better context, would be to think about rap. Remember, the sentences end with some kind of rhyming, and it's easy to remember that because they all rhyme. Episodic buffer is the reason why you see reverse phonological similarity effect. Well, this brings us to the end of this video and the end of this unit. I hope you enjoyed this. Stay tuned. Have fun learning.